This video is a review of some geometry topics that you will be seeing on the ACT. As you can see, there are 6 things that we're going to talk about. Feel free to stop and pause and go back as needed. So the first thing we're going to talk about in this video is the Pythagorean Theorem and common triples that you see that are Pythagorean triples. So we all know the Pythagorean Theorem as a squared plus b squared equals c squared. You might also know it as leg squared plus leg squared equals hypotenuse squared. So the legs are the two sides that touch the right angle. They kind of make an L in a lot of cases. The hypotenuse is the side opposite the right angle, in this case C. So when I look at the Pythagorean Theorem, I can think of it in a squared plus b squared equals c squared, or leg squared plus leg squared equals hypotenuse squared. Common triples you're going to see, 3, 4, 5 is the most common. You know 3, 4, 5 works because 3 squared plus 4 squared equals 5 squared. So that's common. 3 squared is 9, 4 squared is 16, and 5 squared is 25. So 9 plus 16 makes 25. Other multiples of that particular triple that you see often are 6, 8, 10. So that's a multiple of 3, 4, 5. So 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. Another multiple is a 9, 12, 15 Pythagorean triple. So that's 3 times 3 is 9, 4 times 3 is 12, and 5 times 3 is 15. So any multiple of 3, 4, 5 is another triple that you might see, and it might make your life easier to know those multiples of 3, 4, 5. Other common triples that you see are 5, 12, 13. So 5 squared plus 12 squared equals 13 squared. So again, when you see those 3 numbers, the biggest number has to be on the hypotenuse. So once again, the hypotenuse is the longest side. It's the side opposite the right angle. So if you see 3 and 5 in a triangle, it's just important to make sure that the 5 is on the hypotenuse. If you see that, that's the longest number. So just something to think about. The other triples that you might see, another one that's common is a 7, 24, 25. And then the last common one is a 8, 15, 17. So it's just good to review these. Make sure that you know those. Those can make your life easier in a lot of cases. So looking at a problem that involves Pythagorean Theorem, here we have a chord 24 inches long, is 5 inches from the center of a circle, as shown below. What is the radius of the circle to the nearest tenth of an inch? So looking at this picture, you know the distance, if you're talking about the distance from a center to a line, it's got to be a right angle. So therefore that 5 and the chord that is 24 make right angle. So I'm working with Pythagorean Theorem. So when you see that, one of the common things from geometry is that any line from the center bisects a chord. So therefore you know that this piece is 12. So this creates a 5, 12, 13. So if you know your triples, you should know that that part is 13 right away. If you're not 100% familiar with the triples, you can still do this by doing the Pythagorean Theorem. So that would look like 5 squared plus 12 squared equals r squared. This would give me 25 plus 144 equals r squared. 169 equals r squared. And then I can square root it. Either way, you get the answer D, 13. It's just a little bit quicker just to know your triples. So you see that, like, you could have saved yourself 20 seconds maybe, you know, if you just know your triples. And there are probably a few questions on the test that require you to use a triple, and if you remember that triple, it might help you to do the problem a little bit quicker, maybe save you some time so that you can then use some of that time later on in the test. So the next thing we're going to talk about are angles and triangles and parallel lines, and these problems pop up a lot. You're going to see usually a picture with some things given, maybe some parallel lines, maybe a triangle with some congruent sides, and you got to know which angles are the same, which angles add up to 180, and things like that. So this is a typical picture. You're going to see a lot of triangles, angles, parallel lines, things like that, where you got to know how to work with it. So there's some tips that I'm going to give you here that hopefully will help you with these type of questions. So number one is arrows always mean that lines are parallel. So these 2 arrows that you see tend to mean the lines are parallel. And when lines are parallel, what that means is you're going to have some congruent angles. They wouldn't be giving you parallel lines unless you wanted to say some angles were congruent. And you're going to see a couple congruent angles. Like these angles are alternate interior, if you remember that from geometry, but they're going to be the same. The other thing that you're going to want to make sure you know is like angles that are on the same side of parallel lines, kind of like these. Okay? If you're thinking like a parallelogram, those angles add up to 180. So like this angle here and then this angle here would be adding to 180. So that's just kind of a general tip that you want to make sure
you know. So that's one thing. The other thing is angles in a triangle add to 180. That's a common thing that you probably already know. Angles forming a line or a linear pair add to 180. So what that looks like is if I just have two angles that make a line. So for example, this angle and this angle, they would have to add to 180. A straight line is 180 degrees. That's a common thing that you're going to see. And then the last thing that a tip that I want to give you is that isosceles triangles have two congruent sides and therefore two congruent angles. So therefore, looking at this picture here, this triangle is isosceles. So if I'm looking at the triangle, being isosceles, you know that the base angles are congruent. So there's a common thing that's going to pop up on ACT type tests is parallel lines, angles that add to 180, angles that are congruent. All that stuff is going to be important to be able to recognize. So let's look at a problem here. So this is not numbered, but in the figure below, B is on AC, E is on DF. Okay, so some information there that really doesn't mean a whole lot. AC is parallel to DF. Okay, so there you got parallel lines. So I'm going to put those arrows on them just to make sure I know that. So and BE is congruent to BF. So that's giving you this. And they're already marked that they are congruent, so you don't really need to make sure, you don't need to mark that information. It says, what is the measure of angle DEB? And there's a question mark on it. So typically triangles or triangle problems, angle problems are going to give you what you're trying to find. There's going to be a question mark. Very seldom are you going to have to figure out what you're trying to find. There's a big question mark on the angle. That's what I'm looking for. So I'm going to use a lot of the tips we just talked about. Number one, alternate interior angles are the same. So since these lines are parallel, I got that Z shape going on. So I know already that this angle in here is 35 degrees. So that's one fact. Okay, so there's parallel lines, alternate interior, you make that Z shape, you got those alternate interiors are the same. Now, you know that this triangle here is isosceles. It's got two sides equal. Well, isosceles we just talked about. If two sides are equal, two angles are equal. So I'm going to say this angle is 35. Okay, so there you got these two sides equal, make the two base angles equal. All right, and then last, I'm still trying to find angle DEB, and you know that this angle here, which is 35, and this angle here add up to 180. They make a straight line. So there's that 180 again. So in this picture, you got angles are equal, angles add up to 180, but it's all kind of just making sure you remember those little tips. So in this particular case, the angle in question, angle DEB, plus the angle I just determined, 35, make 180. So to find DEB, you just subtract 35 from 180. So the answer to this one is very quickly 145. So just knowing some of these tips, some of these basic geometry tips is going to help you on questions that look like this, and there are quite a few on the ACT. So the next thing we're going to talk about are 45-45-90 triangles and 30-60-90 triangles. These are two common things that you saw in geometry, and it's just good to review these two things. So looking at the 45-45-90 triangles, this has been a while since you've seen this. The ratio from leg to leg is 1-to-1. They're the same. This is an isosceles triangle. The hypotenuse is √2 times the size of the legs. So what this looks like with x's, you call the two legs x. They're both the same again. The hypotenuse would be x times √2. So this is just a common thing that happens a lot. You see it a lot in squares. So if I want to find the diagonal of a square that has sides 3 and 3, if I just know my 45-45-90 triangle, I know that the diagonal is 3√2. All right, and the same goes opposite. If I knew the diagonal was 3√2, I can go backwards and say the side was 3. So just different things like that. Looking out for the 45-45-90 triangles. Again, they show up commonly in squares. The other special triangle that we're going to talk about are 30-60-90. 30-60-90 are a little more difficult because every side is different. It's not like 45-45 where two of the legs were the same. Here you got a short leg, a long leg, and a hypotenuse. So the ratio is 1 to √3 to 2. So the short leg times √3 gives me the long leg. The short leg times 2 gives me the hypotenuse. So this shows up commonly in equilateral triangles. So if I have a triangle in which all three sides are the same, if you drop an altitude in that triangle, 30-60-90 triangles are created. So for example, if a triangle has a side of 16, then you know that this part of it is 8, and then therefore the long leg, which is the height of this 30-60-90, is 8 √3. This shows up all the time, and you know that it's a 30-60-90 because in an equilateral triangle, the angles are all 60, making this 30, 60, and 90. But something to look out for. Just make sure you know that ratio. Again, it's leg. Short leg is 1. Long leg would be 1 times root 3. And the hypotenuse is the short leg times 2. Just little things to look out for.
The next thing we're going to talk about is another important topic that pops up in the ACT quite a bit, and that is SOHCAHTOA, or sine, cosine, and tangent. These are your trig ratios. So SOHCAHTOA is the way we remember which sides to use in each ratio. So for example, SOH means the sine of an angle, theta, equals the opposite over the hypotenuse. So there's your sine equals opposite over hypotenuse. Cosine, C equals adjacent over hypotenuse, CAH. And then the tangent, TOA, TOA, the tangent equals the opposite over the adjacent. So just things to remember. These are very common questions on the ACT. So looking at an example, for instance, if I look at this picture here, if I'm looking at angle A, the opposite side is A, the adjacent side is B, and the hypotenuse is C. The hypotenuse will never change no matter what angle I'm looking at. If I'm looking at angle B, the opposite now is little b, the adjacent is little a, and the hypotenuse is clearly still C. So depending upon which acute angle you look at will determine which side is opposite, which side is adjacent. So let's look at the first one. So this is the sine of angle A equals, if I'm looking at the so is opposite over hypotenuse. So therefore I'm looking at angle A, the opposite is little a, the hypotenuse is C. So therefore the opposite, little a, hypotenuse, C. So take your time with these. These questions should be slam dunks. If you just know your ratio and know your SOHCAHTOA, you should be good as far as setting up the ratio is concerned. Cosine of angle A, once again, I'm looking at angle A. The cosine uses the adjacent and the hypotenuse. So that I'm looking at angle A. Little a is the opposite, little b is the adjacent, and C is the hypotenuse. So I got little b over C. So the ratio for the cosine of angle A would be little b over C. Alright, so the last one we'll look at is tan of angle B. Well, angle B is over here. Right, so I'm not looking at angle A anymore. I'm looking at angle B. So the opposite now is little b, and the adjacent is little a. So you see how the opposite and the adjacent flip depending upon what angle you're looking at. So therefore, if I'm looking at tangent, that's TOA. So the tan equals the opposite over the adjacent. So if I'm looking at this, the tan of angle B equals opposite little b, and the adjacent to angle B is little a. So once again, opposite and adjacent flip depending upon which acute angle you look at. Alright, so looking at an example of what this may look like on the ACT, it says for a right triangle, triangle RST shown below, what is the tan of angle R? So here's angle R. So you got to make sure you look at the correct angle. So the tan is the opposite over the adjacent. So once again, if I was looking at T, this would be opposite, this would be adjacent. But since I'm looking at angle R, opposite is little r, adjacent is little t. So tan, TOA, opposite, adjacent. I'm looking at the tan of angle R as the opposite little r over the adjacent little t. So I'm looking for r over t. In this case, that is G. So these should be slam dunks. Hopefully, after a little quick review, they will be. The next thing we're going to review are area, perimeter, and volume formulas. Sometimes the ACT will give you formulas, especially when the formula is complicated, but a lot of times they're just going to expect that you know simple formulas such as the area of a triangle, a rectangle, a square, a parallelogram, or a circle. So it's good to review these. If you want to write these down or do whatever you need to do to remember them, feel free. So looking at the first one, the area of a triangle. So the area of a triangle requires two things, the base and the height. So looking at this particular picture, the height always makes a right angle with the base. And the height sometimes lands outside the triangle. In an obtuse triangle, and a triangle where this one angle is bigger than 90, a lot of times the height will be outside the triangle. Something to look out for. The next thing is the area of a rectangle. So rectangles are just base times height. That's an easy one. That's probably one that you learned in like second grade or something. But it does pop up a lot on the ACT. Maybe not in that basic of a format, but it does show up. Area of a square, side squared. Okay, so if you have two sides that are the same, you just side times side or side squared. You could also think of it as a rectangle and just take base times height. The next one is a trapezoid. So the trapezoid has a little bit of a different formula. It's got two bases. So I like to think of the trapezoid as kind of like a triangle, except it's got two bases that you add together. So if you look at the area of a triangle, which is 1/2 base times height, this is kind of like 1/2 base 1 and base 2 times height. So it's kind of the same thing. You just kind of add the bases together. So that's kind of how I think about a trapezoid, is kind of like a triangle with the top cut off. So the other ones
area of a parallelogram. It's very similar to the area of a rectangle. You just got to watch out for the fact that the height and base still need to form right angles. Do not call this side of a parallelogram, this slanty side, don't call that the height. That's going to be the typical mistake students are going to make. Area of a parallelogram is base times height. And then last but not least is probably one of the more important formulas you'll ever see as far as area is concerned. That's the area of a circle. Okay, area of a circle is pi r squared. And I always tell my students in geometry, if you remember nothing else from geometry, remember the Pythagorean Theorem and then the area and circumference of a circle, because these are things that are just never going to go away. Okay, so this pops up on the ACT. Area of a circle is pi times the radius squared. All right, so some important perimeter formulas to remember. Most of the time, perimeter can be found by adding all the sides, but in some cases, you got a rectangle in which you have a length and a width. Sometimes you're going to need to know 2L plus 2W is the perimeter. There might be a formula or some kind of a different kind of question that doesn't just ask you what the perimeter is, but instead maybe gives you some different kind of information in which you need to know that. The other perimeter formula isn't really perimeter, it's circumference, and that's the circumference of a circle. So like I was just saying, 2 pi r, it's key to know that. All right, so some common volume problems that you're going to, or formulas that you're going to encounter are cylinders, pops up on the ACT, the volume of a rectangular prism, or a box, if you will. And then the last one is the volume of a prism of a different shaped base. So the volume of a cylinder is the area of the base times the height. In this case, the area of the base is a circle, so it's pi r squared. The height is h. The volume of a box, if I have the 3 dimensions, it's simply just multiply the 3 together. So that's a common one that you're going to see, and that's an easy way to do it. And then the volume of a prism is the area of the base times the height. So very similar to a cylinder, in which you take the area of the base, which in this case is a circle. In the volume of a prism, you take the area of the base times the height. The area of the base may not be a circle. It might be a pentagon like it is in this case, but make sure that you find area if you're doing this, or they give you the area or something like that. So the area of the base times the height will give you the volume of a prism. All right, so the last thing we're going to talk about are finding area and perimeter of odd shapes. So very often you'll see questions that give you a rectangular shape where you have to either find the area or perimeter of that shape based on what they give you. They're not going to give you a lot of straightforward stuff on the ACT. The questions they ask you require you to think a little bit, and they require maybe a little more work than just a straightforward area problem, which makes you think. So looking at this, the tip that I give you is break it up. Break it up into pieces. So looking at this particular problem, it says, what is the area in square feet of the figure below? So if I look at this thing as a total figure, you see that you got 6 sides. You could call it a hexagon. But my tip is break it up. Make it 2 rectangles. If I make this thing 2 rectangles, and you don't have to break it up that way. If you want to, you can break it up this way. So you're not limited in the way that you break it up, but the idea is that you're going to create 2 rectangles and find the area of each and add them up. So looking at this, the first rectangle is 25 by 5. Well, the area of a rectangle that's 25 by 5, we just talked about, is base times height. So therefore, it would be 25 times 5, or 125 feet squared. Once again, all I did to get that was I multiplied 25 times 5. So that was the first rectangle, so that takes care of the top part. Now I got to figure out the area of this rectangle down here. So the common error students will make here is to use this 15. That 15 is not a side of that blue rectangle I just drew. You have to figure out what the other side is based on what they give us. So 15 is the whole side here, and I know that part of that whole side is 5. So that kind of tells me what the other part is. In this case, would be 10. So that is the dimension that I want to use. Once I figure that out, that 15 kind of gets thrown out the window. So now I got a 15 by 10 rectangle. 15 times 10 is 150. So 150 feet squared. So the total area of this shape equals 150 plus 125, which is 275 square feet. So looking at the answers, that would be H. So once again, break up the problem and make 2 rectangles. So that was how you do an area problem. Let's look at a perimeter problem. So it says, in the figure shown below, each pair of intersecting line segments meets at right angles, and all the lengths given are in inches. What is the perimeter in inches of the figure? So this problem, I have a certain number of sides. We could count them up, but basically what I'm going to do is I'm going to highlight the ones that I know so that I can see the parts that I need to find. So I got all of these are known. These are known quantities. The parts that I don't know, I'm going to highlight in red.
And this is something that you maybe want to do on the ACT if you want to, darken lines that you need to find or whatever using your pencil. However you want to do it is a good way to think about it. But anyways, I need to find those 4 red pieces in order to find the total perimeter. And again, when I'm thinking perimeter, the idea is to add up all the sides. So that's the idea. So add all sides. There's no quick way to do this. There's no formula for the perimeter of this shape, clearly. It's a weird looking shape. You're not going to have a quick, easy way to do this. But we can still find the perimeter by finding those 4 red segments and seeing what they equal. So looking at these 2 vertical segments here and here, if I look at the other side, that's really my only way to know. I see that those things are made up of 4, 6, and 4. So altogether, 4 plus 6 plus 4 ends up equaling 14. So the idea is to say, well, I know that the opposite side is the same as the 2 opposite sides are going to be the same. If it's rectangular, that's going to be true. So then those 2 sides, whatever they are, add up to 14. You might want to call them 4 and 10. It doesn't really matter. As long as they add to 14, we're going to be good. All right, same concept for these 2. These 2 pieces are going to be 26 less 10 and 6. So what I'm looking at there, if I look at these pieces, I see that from here to here, I got 16, right? So this distance here is 16. I know that because this part is 10 and this part is 6. So that piece is 16. So then the rest of this has to be 26 minus 16. So in this case, that's 10. All right, so now I'm looking at the problem, trying to figure out what to do. I'm going to erase the parts that I'm not going to add, and I'm going to circle the ones that I do add. So that's 4, 6, 4 are circled. I got to add 10. I got to add 6. I add my 14 and add my 26. So the total perimeter of this shape, I'm going to start here and go around clockwise. I'm going to say 4 plus 6 plus 10 plus 4 plus 10 plus 14 plus 6 plus 26. Adding those all together with your calculator, you should get 80. So the biggest number on the answer choices is your answer to this question. So the idea, again, find all the pieces. If it helps you to highlight them, that's a good tip. But again, the biggest part about this question is staying organized and understanding, making sure perimeter, you add all the sides.